The anatomy of a hurricane. A hurricane is an intense storm of tropical origin with a sustained wind of at least 64 knots, which is 74 miles per hour, and with a considerably higher gust that form over the warm North Atlantic and eastern North Pacific Ocean. Hurricanes are composed of intense convective cloud thunderstorms that sometimes grow over 50 kilometers in height. These same types of storm in different names in different regions of the world. In the western North Pacific, it is called typhoon. In India, it is called cyclone. And in Australia, it is called tropical cyclone. By international agreement, tropical cyclone is general term for all hurricane type storm that origin over the tropical water. For simplicity, we'll be naming it as a hurricane. So a hurricane has eye, relatively clear at the center. We would call it eye. The cloud align themselves into a spiraling band called a spiraling rain band that actually spiral inward the storm center, where they wrap themselves around the eye. Surface wind increase in speed as they blow counterclockwise inward towards the center. In the southern hemisphere, the wind blow clockwise around the center. In the northern hemisphere, the wind blow counterclockwise around the center. Adjacent to the eye is we call is eye wall, a ring of intense thunderstorm that spiral around the storm center and may extend upward almost 18 kilometers above the sea level. Within this eye wall, we find the heaviest precipitation and strongest wind. So, which in this storm are about sometime 130 knots with peak gust with 160 knot sometime. The model shows that the hurricane is composed of an organized mass of thunderstorm that is actually an integral part of the storm circulation. Near the surface, moist tropical air flow in towards the hurricane center. Adjacent to the eye, this air rises and the water vapor condenses into huge cumulonimbus cloud that produce a heavy rainfall, as much as sometimes it is 15 centimeter per hour or more. Near the top of the cloud, the relatively dry air, having lost much of its moisture, begin to flow outward away from the center. This divergent actually produces a clockwise flow of air, anti-clockwise in the northern hemisphere, several hundred kilometers from the eye. As this outflow reaches the storm periphery, it begins to sink down and warm, inducing clear sky. In the vigorous convective cloud of the eye wall, the air warms due to the release of large quantity of latent heat. This produces slightly higher pressure aloft, which initiate downward air motion within the eye. As the air descends, it warms by compression. This process helps to account for the warm air and absence of the convective cloud in the sky of the storm. As surface air rushes into towards the region of much lower surface pressure, it should expand and cool, and we might expect to observe colder air around the eye, with warmer air further away. But apparently, so much heat is added to the air from the warm ocean surface that the surface air temperature remain fairly uniform throughout the hurricane. So mainly anatomy of the hurricane has an eye, and this eye actually clear patch, clear sky patch, and in the center of the eye a downward wind flow can be observed. Around the eye is a dangerous eye wall. It is the strongest wind we can see, and it is a converging upward wind, and that wind blow all the way up to then again sink down and make the fuel of the hurricane.